right, today we're going to be looking at the graphs of sine and cosine. We start today with the two most basic trigonometric functions, sine and cosine. We will talk about the others later on this week. But sine and cosine, we said, they go in a cycle, right? There are several angles that have sine 0 being 0, or they have a sine value of 0. So that leads us to believe that our graph will be periodic. It'll just graph itself and it'll start repeating and just looking just like a curve there, okay? A repeating curve. So let's look and let's see how we're to graph this sine and this cosine function. We have 5 basic points, okay? We have the intercepts, the place where the graph crosses the x-axis and the y-axis. We have minimum points and we have maximum points, okay? If you notice, just dealing with sine in our unit circle, the highest point we ever get to is 1, right? The lowest point we ever get to is -1, okay? So just for basic y equals sine x, we have a maximum of 1, minimum of -1. Let's plug in some of these quadrant angle points and let's see what happens when we deal with these graphs. So let's look at y equals sine x, okay? And what we want to do is probably extend this out a little bit more. We want to look at 0. We want to look at pi over 2, x equals pi, x equals 3 pi over 2, and x equals 2 pi. Okay? And we want to find our associated y values. Okay? If I put in x equals 0, sine 0 is what from our unit circle? It's 0, isn't it? So I have a point 0, 0. If I put pi over 2 here, sine pi over 2 gives me 1. If I put pi, sine pi is 0. If I put in 3 pi over 2, sine of 3 pi over 2 is -1. And if I put in 2 pi, I'll get 0. So this leads me to believe, and these are continuous graphs with rounded curves. My sine function will look something like this. Okay? Notice, I have those 5 key points that I was talking about. Okay? I have an intercept here, a maximum, an intercept, a minimum, another intercept. Okay? So, if I know these 5 key points in dealing with this sine graph, then I should be okay as far as graphing. Let's look at y equals cosine x. And we're going to look at the sine 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay? So cosine 0, if I put 0, is 1. So I have a point 0, 1. Okay? And we're getting these y values from what? Our unit circle. Cosine of pi over 2 is 0. So I have a point pi over 2, 0. Cosine pi is -1. So I have a point pi, -1. Cosine 3 pi over 2 is 0. I have a point 3 pi over 2, 0. And cosine of 2 pi is 1. So I have a point 2 pi, 1. And if I draw this graph, that's my basic cosine graph. Okay? Sine and cosine. Now, as I said before, we had a maximum of 1, intercept, minimum -1, intercept, and a maximum again. So these 5 points are key in graphing. Now, we talk about that we had a maximum of 1 and a minimum of -1. Well, it may be the case where if I have a 2 sitting out here, then that would change, wouldn't it? My maximum will be 2. My minimum will be -2. Well, this leads us to a discussion of the amplitude and the period. Okay, the amplitude tells us how high and how low this graph will go. So let's look at the amplitude and the period. And for our discussion, we're going to look at general sine graphs, something like D plus A sine BX minus C. And we're going to talk about what the D, the A, the B, and the C mean, okay? And we're going to look at Y equals D plus A cosine BX minus C. And you want to see what do these constants do to these basic graphs, okay? What do they do to the basic graphs? Well, is the absolute value of A, which is the coefficient of that sine or cosine, if that is greater than 1, then what we have is a vertical stretch. And if you remember from Math 112, pre-calculus, we did these type things. We did like what, 1/3, what was like x squared, or either 2 times x squared, and we noticed one was a vertical stretch, which made the graph more narrow, right? One was a vertical shrink, gave us a wide graph. Y'all remember those things? Same concept here. If A is less than 1, then what we have is a vertical shrink. That means our graph is wider. And all this means is that we have an amplitude of absolute value of A. The amplitude means that A will be as high or as low as that graph will go. That's the amplitude. So, the graph ranges, or we should say the graph of just the basic y equals a sine x or y equals a cosine x ranges between -a and a. Because when we go to adding this d here, it will either push our graph what, up or down? Y'all remember that vertical translation? That d will push it up or down. So, but if we just have a cosine x or a sine x, then that tells us the range of our graph. Okay? The period. We can find the period of this graph by 2 pi over b. This tells us the period. Now, what does that mean? Well, notice that here on this graph, one complete period on the normal sine graph ranges from 0 to 2 pi, okay? From here, 0 to 2 pi. But depending upon this b, my graph could be, what, compressed in a little bit, or it could be stretched out. So, what I'm trying to get at is that, hey, if I know the period of this graph, then I can still get my 5 key points. It may not range from 0 to 2 pi. It may range from 0 to 4 pi, okay? But I can use the period to find how compressed or how stretched the graph is on a horizontal level, okay? So, as a note, If B is between 0 and 1, then we have a period greater than 2 pi. And this represents a horizontal stretch. Okay? If B is greater than 1, then we have a period less than 2 pi. And this represents a horizontal shrink. Okay? And we need to know what that period is. So we're going to look at an example or two where we're just going to find the period and the amplitude. Okay? So let's find the amplitude and the period. First example. Suppose we have y equals -3 sine x over 3. What's our amplitude? It's the absolute value of A. What is A? Coefficient of the sine, which is what? Okay. So amplitude is 3, the absolute value of -3, which is 3. Now, what is our period? What is B in this problem? What is B? 1/3. B is 1/3. Notice, if we go back here, we have D plus A sine BX. So B is the coefficient of the X, which is 1/3. So our period is 2 pi over B, right? Period, 2 pi over B. B is 1/3, which means our period is what? 6 pi. So we have a what? Horizontal what? Stretch. Okay, we have a horizontal stretch of this graph. All right, let's talk about translations now. Translations. Translations. The constant C in the general equation y equals A sine bx plus C and y equals A cosine bx plus C. Excuse me, it should be bx minus C. Bx minus C. This creates a horizontal translation. Okay? It creates a horizontal translation. It either moves that graph left or right. Right? Okay? The graph completes one cycle from, now, bx minus c equals 0 to bx minus c equals 2 pi. Why is the bx minus c equals 0 and 2 pi? Well, because in our original sine and cosine function, it starts at 0, it ends at 2 pi. So if we set this argument of the sine and cosine, bx minus c equal to 0 and 2 pi, then what this means is that if I solve for x, x here is c over b, and x here will be what? C plus 2 pi all over b, right? Which leads me to believe that one cycle of this sine or cosine function in this form, x will range from c over b to c over b plus 2 pi over b. Okay? So this tells me my cycle. It kind of tells me where I start and where I end this graph. Okay? May not start at 0. Okay? Kind of tells me where I start and where I end. So what we're about to do now and for the rest of today is to graph several of these. Is to graph several of these using these 5 key points. So let's graph. Now the first example, they want us to graph 2 equations on the same set of coordinate axes. Okay? What they want us to see is how sine x differs from sine x over 3. Okay? They want us to see how sine x differs from sine x over 3. So we're going to graph these on the same set of coordinate axes. Now, f of x equals sine x. And this is something that you need to learn. Okay? With this one, the amplitude is 1. Okay? We'll have to get this basic sine graph in our head so that we can know and easily construct this graph. The period is 2 pi. Okay? The period is 2 pi. Is what? 2 pi over b, and b here is what? 1. Okay? Which leads me to believe that my 5 points, remember we start with 0. The next one is 2 pi over 2. The next one is pi. The next one is 3 pi over 2. And the last one is 2 pi. Okay? And we did this rather quickly because we just graphed this.
Where did our 2 pi come from? The period?
The period. We're looking at this basic sine graph here. So we've already constructed that graph. We know it ranges from 0 to 2 pi. But the period is 2 pi over b. Right? 2 pi over b. What is b? B is the coefficient of the x. So b is 1. So that gives me 2 pi. Okay? So for this graph, you know, we've already graphed it. We know what this looks like. But if we look at g of x, this becomes a little different now. Sine x over 3. What's our amplitude here? 1. Somebody said 1. And what is our period here? It is 2 pi over b. And what's b? What is b? 1/3. Which means now we have what? 6 pi. So I have a little work to do here, don't I? Because I need to figure out how I get these 5 key points now. Okay? I have 5 points, but I have 4 equal parts, or 4 intervals. Does that make sense? 5 points, but really 4 intervals. And we'll show you on the graph that we're going to graph how there are 4 intervals, since I've already erased this one, but really 4 intervals. So what I need to do is I need to divide this 6 pi up into 4 equal parts. Okay? Now, being that I don't have this minus c stuff, bx minus c, I just have bx. I'm still starting at 0, right? Right? Over here, this translation would occur when we had a c in this graph here. We only have the bx portion. We don't have the c portion. So my graph is not moving over to the right, to the left. I'm still starting at 0. Does that make sense? Still starting at 0. But now I'm going to have a beginning point of 0. I know I'm going to have an ending point of 6 pi. Where are my other points going to come from? Well, I need 4 equal parts. So I say, hey, what is 6 pi divided by 4? What is that? 6 pi, or maybe we should do it like this just to not confuse ourselves, divided by 4 to represent 4 equal parts. This gives me 3 pi over 2. And what that means is that from one point to the other, I'm going to have a length of 3 pi over 2. Say that again. Okay? Let's say that again, because it can be confusing. I have 5 critical points here. Okay? Even though I have 5 points, I have 4 intervals. And we can see here, from here to here is 1 interval, 2 intervals, 3 intervals, 4 intervals. Okay? I have 4 intervals, which means that since I don't have this minus c portion, I'm still starting at 0. This period, since I'm starting at 0, this period is of length 6 pi, which means I'm going to end at 6 pi. But I have to somehow break this up to get my other points, because we have 5 points. So how do I get those other 3 points? Well, I want 4 intervals. I want them equally divided. 6 pi divided by 4 gives me 3 pi over 2, which means I'm going to have a length of 3 pi over 2. So what do I say? I say 0 plus 3 pi over 2 gives me 3 pi over 2. How do I get this one? I add 3 pi over 2 to this one, right? So here I get 3 pi over 2 plus 3 pi over 2 is what? 6 pi over 2 or what? 3 pi. Then I go over here and I take my 6 pi over 2 and I add another what? 3 pi over 2. This gives me what? 9 pi over 2. And if I've done something right, when I add 9 pi over 2 plus 3 pi over 2, I should get what? 6 pi. Okay?
How are we supposed to find those points on our graph?
Because we've only found the x-coordinate now, right?
Yeah.
You have to find the y-coordinate. You can do it by using your calculator or your unit circle. How do we find these points? Or we can think about, too, that these points that I'm picking, because I have not shifted up or down, and we'll get to shifting up or down in a minute, this D shifts up or down. Because I've not shifted up or down, those 5 points are still going to be my what? Intercepts, my minimum, and my maximum. Okay? Or you can say sine 0 is 0. What's sine 3 pi over 2 from our unit circle? It's 1. 3 pi is not on the graph, but it's coterminal to what? Pi, right? Coterminal, adding and subtracting 2 pi. See, all these things, you can't forget them. Have to take them on with you. 9 pi over 2 is coterminal to what? 3 pi over 2? Because this is what? Well, no, that's 3 pi in it. We need to subtract 2 pi, but 9 pi over 2, you can go on your circle. Okay? But here we have for this sign 0, 1, 0. What was the pattern? Negative 1, 0? The sign? You need to know what that basic sign graph looks like. And the pattern will be the same until you go to shifting up and down, and to the right and to the left. Here all we're doing is scaling this x factor. So what does my graph look like? What's my graph look like? So I have pi, 2 pi, 3 pi, 4 pi, 5 pi, and 6 pi. Now, I can graph my normal sine graph here. The sine graph I have, and I know my amplitude will run from what? 1 to -1. I have 0, 0. I have pi over 2, 1, which is somewhere halfway there. Okay? I have pi, 0, and I have 3 pi over 2, -1, and 2 pi. So this is my basic sine graph. This is f of x. What is g of x? G of x starts with 0, 0. And then we go to what? 3 pi -1, 3 pi 1, which is here. 3 pi over 2, 1. Then we go to 3 pi 0. And then we go to 9 pi over 2, -1. And then we go to 6 pi 0. So this thing is g of x. I guess I should have used 2 other colors in yellow and green. They kind of look alike. But notice, this is the basic sine graph f of x. G of x is a what? Horizontal stretch of the same graph. Period is just different. Okay? Just stretching it out. Questions?
I'm not really sure on how you got the y.
The y's here? 2 ways you can do it. You can put in your calculator. You still need to figure out what sine 0 over 3 is. 0, right? Here, what is sine 3 pi over 2? If I put 3 pi over 2 here, what happens? 3 pi over 2 divided by 3 is pi over 2. If on your unit circle, you find sine pi over 2. We didn't explain it that way. We explained it talking about coterminal angles. But if you substitute this here, like you put it in sine 3 pi, well, 3 pi over 3 is just sine pi. That's 0. Does that make more sense? And then if I put 9 pi over 2 here, I need to get 9 pi over 2 divided by 3. And that should reduce to 3 pi over 2. And then 6 pi will reduce to 2 pi. Other questions? And I do understand this is overwhelming. It is. Let's look at another one. We'll look at a cosine graph now. They want us to graph on the same set of axes 2 cosine 2x and negative cosine 4x. Okay, y'all, what does that negative do out in front of that cosine? What does it do? See if y'all remember from 112. It's a reflection in what? I'm giving you a hint. Reflection in the x-axis, right? Reflection in the x-axis. When the negative is in front of that function, it's a reflection in the x, okay? So not only are we dealing with cosine, we're dealing with the reflection in the x. What does the reflection in the x do? Kind of turns that graph upside down. So we got to keep all those things in mind. So here, I need to note that I have a reflection in the x-axis. Okay? But let's deal with this first one. Let's deal with f of x equals 2 cosine 2x. Let's deal with this one. What's my amplitude? Amplitude is 2. What's my period? It is 2 pi divided by b. What is b in this function? 2, which means my period is what? Pi. So now I'm shrinking everything in. Shrinking everything in here. So, knowing that my x will range from 0 to pi, how do I know it starts with 0? Because sometimes it may not start with 0. But I don't have that bx minus c. I don't have that minus c. When that bx, all I have is bx here. But when I have that bx minus c, then that tells me I'm going to be shifted. And that I may not start at 0, or start at the point 0. But here, since I don't have that c portion, I'm starting at 0, I'm in that pi. So I need to break this down into what? Equal length. I need my intervals to be in equal length. I have 4 intervals, so I end up doing this what? Really, and we should think along this notion, we should think about pi minus 0 divided by 4. We should think about that, because if I don't start at 0, I have to subtract whatever this number is from pi and then divide it by 4 to get my what? How long, or the length of my whole graph, or the length of that one interval, which means here my interval should be pi over 4 apart. So I start with 0. I know I'm going to have how many points? 5. And I'm going to end with what? Pi. Start with 0, end with pi. So 0 plus pi over 2 is plus pi over 4 is pi over 4. Right? Then to get this one, I do what? Pi over 4 plus pi over 4, which is 2 pi over 4, which reduces to what? Pi over 2. Right?
You divide each of them by 4?
We're adding this. After we divide by 4, we add pi over 4 to 0 to get this one. Then we add pi over 4 to this one to get this one.
Well,
And then,
why did you divide by 5 since there's 5?
Because there are 4 intervals. 5 points, but 4 intervals. Okay? To get this one, notice what I'm doing. I'm taking this unsimplified version to add my power 4 to. But I'm putting my simplified version here. This gives me what? 3 power 4. And then my 3 pi over 4 plus pi over 4 should give me pi. And it does. Okay? Are we seeing this? Okay. Now, where do I get this other stuff from? Well, I go back to my equation. 0. Cosine of 0 times 2 is 0. Cosine 0 is 1. 1 times 2 is what? 2. But just knowing the basic graph of my cosine function, I knew my highest point would be 2 because that's the what? Amplitude. And I haven't added or subtracted to push it up or down. Pi over 4. 2 times pi over 4 is pi over 2. Cosine pi over 2 is 0. 0 times 2 is 0. So we're seeing where these y values are coming from. Putting them back into the function. Pi over 2. Pi over 2 times 2 is pi. Cosine pi is what? What's cosine pi? Is it negative 1?
Yeah, it's 2 cosine.
So it's negative 2. 3 pi over 4 times 2 is what? 3 pi over 2. And cosine 3 pi over 2 is 0. 0 times 2 is 0. So what do we think this is going to be? 2. Just knowing the basic cosine, it's going to be 2. So let's go ahead and let's draw that first one. So we have the point 0, 2. which is here. Power 4 is 0. Power 2, negative 2. And 3 power 4 is 0. And pi 2. Okay? This is f of x. How about g of x? G of x. We know it's a reflection in the x. So we know it's going to kind of be turned upside down as far as the x-axis goes. What is our amplitude here? What's the amplitude? Amplitude is 1. The absolute value of that constant, absolute value of negative 1 is 1. What's our period? It's 2 pi divided by b. b is 4. So we're going to go pi over 2. Do I start with 0? Yes, because I don't have that bx minus c portion. So my x will range from 0 to pi over 2. Okay? 0 to pi over 2. Now, I have to divide this interval up into 4 equal parts. So what's pi over 2 divided by 4? Pi over 8. So what this means is I start at 0. And I'm going to end at pi over 2. But I have to add what? Pi over 8. 0 plus pi over 8. Pi over 8. Right? Pi over 8 plus pi over 8. 2 pi over 8, which is what? Pi over 4. Then down here I have my 2 pi over 8 plus pi over 8, which is what? 3 pi over 8, right? Then down here I have my 3 pi over 8 plus pi over 8 is 4 pi over 8, which is 2 pi. Okay? Now, even if I didn't recognize that that negative sign will reflect it, it's okay. Because when I put my points in there, it will reflect, what my point should be. So when I put 0 up here, cosine 0 is what? 1. But that negative makes it negative 1. Okay? When I put my pi over 8, 4 times pi over 8 is pi over 2. Cosine pi over 2 is 0. 0 times negative 1 is 0. So it's really not changing my intercepts. It's just switching my minimum and my maximum point. Pi over 4 times 4 is pi. Cosine pi is what? Negative 1, but that negative makes it what? Positive 1. And then if I put my 3 pi over 8 here, I have 3 pi over 2. Cosine 3 pi over 2 is 0, which gives me 0. And this, if I put pi over 2, I have 2 pi. Cosine 2 pi is 1, but that negative makes what? Negative 1. So what I have here is 0, negative 1, which is here. I have pi over 8, 0, which is here. I have pi over 4, 1, which is here. I have 3 pi over 8, 0, which is here. And pi over 2, negative 1, which is here. Now, it's kind of hard for me to draw this thing upside down, but hey. Notice, g of x is the upside down cosine. F of x is the regular, but our periods are different. Okay, so get another one. Suppose we do have this Let's see. Suppose we have this D portion. Remember, it was D plus A sine bx minus c. Suppose we have that D portion. And that D portion will either shift our graph vertically up or down, right? So let's suppose we have one like that. Well, they put that D in there. And they want us to graph this on the same set of axes. Suppose we have 4 sine pi x, and we have g of x equals 4 sine pi x minus 3. Now, we have to be careful here, because you may think that's bx minus c, and it is not. This can be rewritten as negative 3 plus 4 sine pi x. If it were meant for the 3 to go with the argument of sine, then it would have parentheses, okay? So can we see how it could be a little confusing? It can be. Now, as I said, if that 3 was included, we have what? Some parentheses. If we don't, which means that 3 is separate from that pi x, separate. Which means we can put it up front, and it's going to, this graph is going to, from this graph, it's going to go down 3 units. So, if I can get this graph with my points, I can just shift everything 3 units down and be okay, right? So let's work with that f of x graph. And let's try to shift for the g of x 3 units down. So for f of x, my amplitude is what? 4. My amplitude is 4. My period, 2 pi divided by what? What is the coefficient of that x? Pi, which means my period is just 2. It's just the number 2. Now, I don't have that bx minus c going on, which means I start where? 0. Start at 0. So, my x will range from 0 to 2. I need 4 equal parts, right? Which means 2 divided by 4 gives me 1/2. So, I'm going to start at 0. I need what? 5 points, 4 intervals. I'm going to end at 2. So 0 plus 1/2 is 1/2, right? 1/2 plus 1/2 is 1. 1.5 is 3/2, and 3 halves and 1/2 is 2. Okay? Right? So I need to figure out my other points. Well, put it up here. Sine 0 is 0. Sine pi times 1/2 is what? 1 times 4 is 4. We seeing where these coming from? Put 1 up here. 1 times pi is pi. Sine pi is 0. 0 times 4 is 4. 3 pi over 2. Sine 3 pi over 2 is -1, which makes this -4. And if I put 2 here, sine 2 pi is 0. So what this means is I can go ahead and draw first graph. And I can go ahead and label my points as 0, 1/2, 1, 3/2, 2, with an amplitude of 4. So I have 0, 0, 1/2, 4, 1, 0, 3/2, -4, and 2, 0. So this is my f of x. Now, let's look at the g of x. -3 plus 4 sine pi over x. Now, my period is the same, is it not? Period. 2 pi over b. B is the same both times. My period is the same. I don't have that bx minus c. I start with the same 0 and go to 2. What changes? The y coordinates change. And the y coordinates change by what? 3 units down, which means I can do what to each of these y coordinates? Subtract 3. Okay? I can subtract 3 because this pushes the graph 3 units down. And because my basic graph was the same, I have the same period. I have the same length and intervals. I have the same starting point, ending point. So, -0, -3. 1/2, 1. 1, -3. 3/2, -7. And 2, -3. Which means my graph looks something like this. Okay? 3 units pushed down. Okay. Questions so far? And I know you're probably wondering, how in the world is she going to test us over all this stuff in an hour and 15 minutes? Right?
That's what I was wondering.
I knew it. I'm wondering too, because I hadn't figured it out yet.
Take home test.
Ooh, you don't want one of those things.
Multiple choice.
You're not getting one of those things. But you don't want to take home test, because I feel if I give a take home test, I ought to make you learn lots and lots of things.
True, false.
You know? And take home tests are generally too hard. And the last time I gave one, they said, please don't give us another one.
Alright, we don't want one of those.
You don't want one?
We just want multiple choice, right?
I don't know about multiple choice. I don't know.
Multiple choice.
Wow, we're in a new one now.
Same book.
Huh?
Same book.
It was. I don't know how I'm going to test you. It'll be something you can do, though. Let's look at one of these that we have a C. We haven't done one where we had the C, have we? BX minus C? Can we stretch our brains some more to do one like that? Oh, I don't want to hear that negative answer. I want to hear a positive answer. Uh-huh.
Okay, so you probably explained it already, but how did you get the Y's again?
How do we get the Y's? Well, it depends. Well, this problem, for this one, but I can't even talk today. Specifically for this one, we got our Y's here by doing what? Replacing here, right? We place the x here for the first one, for f of x, right? 0 times pi is 0, sine 0 is 0, 0 times 4 is 0. Okay? 1/2. Pi times 1/2 is pi over 2. Sine pi over 2 is 1. 1 times 4 is 4. How do we get these? Well, these we noticed that this graph was shifted 3 units down, so we subtracted 3 from our y values.
Yeah.
But it'll work the same way. If you put 0 here and do all the work, you get -3. Okay? 0. 0 times pi is 0, sine 0 is 0, 0 times 4 is 0, 0 plus -3 is -3.
Then we do this, which is y equals 2x.
Right. You just simply replace them. Substitute them is the correct word and get your y value. You ready to tackle that one over there? This may be our last one today, okay?
I'm ready for it.
You ready? All right. This is the first one we had, this bx minus c. Well, here it's plus c, but that's okay. What's our amplitude? 4. What is the period?
So how do we use the period again?
2 pi divided by b. And what is b? The coefficient of this x, which is 1. So our period is 2 pi.
Okay, I see.
Okay? Now, this is the first one. Notice all of our problems been starting where? 0, right? But when we bring this x plus pi over 4, we don't start at 0 anymore. Where do we start? You remember we had that bx minus c equals 0 or bx minus c equals 2 pi. Remember, we got that interval, right? So let's look at this bx minus c. Bx minus c is generally equal to 0, which means x is negative pi over 4. And we have this interval, or this portion of the interval, bx minus c equals 2 pi, which means x is 2 pi minus pi over 4. What's 2 pi? 8 pi over 4, which means this is what? 7 pi over 4. So now, my x's range from negative pi over 4 to what? 7 pi over 4. Okay. If you remember, in all the times we did, we started 0. Started 0. Here, because we have this bx minus c, is going to be pushed left or right, okay? So we need to figure out where to start and where to end, okay? So where do we start? Well, we set this bx minus c equals 0 to get our starting point, and set it equal to pi over 2 to get our ending point. Because that, from 0 to 2 pi, is the basic length of one cycle of that sine graph. So this tells me that I'm starting here, I'm ending here. Now I need to figure out the length of my intervals. Well, first of all, I got to find the length of this graph. How do I do that? Well, I need to do, remember we did this minus 0, but we need to do this end point minus our negative pi over 4, which is what? 8 pi over 4, right? Which is 2 pi. So my graph still will be 2 pi lengths long. But that only tells me what that should be. I need to now divide by 4, right, to figure out how I get my points. What do I add to these things? So, 2 pi divided by 4 is pi over 2. And this gives me my length of my intervals. So, what does all this stuff mean? This means now I can get my 5 points. I start at what? Negative pi over 4. I end at what? Okay? What do I add to get to my next point? Pi over 2.
How do we get that one?
How do we get the pi over 2? After we found out the length of this cycle for sine by doing 7 pi over 4 minus negative pi over 4, I get my 2 pi. Then I need my 4 interval, so I can divide 2 pi divided by 4. That gives me pi over 2. So I start with negative pi over 4. Well, this point will be negative pi over 4 plus what? Pi over 2. Right? And getting a common denominator, y'all know how to do that? And all that good stuff, that becomes pi over 4. Do we need to see that little algebra step, getting a common denominator? Okay. Then from here, I need to do what? Pi over 4 plus pi over 2. And when I do all that, 3 pi over 4. And to get this one, 3 pi over 4 plus pi over 2. And I get 5 pi over 4. And from here, 5 pi over 4 plus pi over 2 should give me that point. So you do have a way of checking yourself, okay? If you get your endpoints right. Okay? Now, where do I get these other values from? Well, put negative pi over 4 here, negative pi over 4 plus pi over 4 is 0, cosine 0 is 1, 1 times 4 is 4. Let me look at that again. Yeah, it's 4. Okay, then I have my what? Pi over 4 plus pi over 4, pi over 2, cosine pi over 2 is 0. 0 times 4 is 0. Okay? 3 pi over 4 plus pi over 4 is 4 pi over 4, which is pi. Cosine pi is negative 1, makes negative 4. 5 pi over 4 plus pi over 4 is 6 pi over 4, which is what? 3 pi over 2. Cosine 3 pi over 2, 0. And this one's going to be what? Our amplitude of 4. So what does my graph look like? Negative pi over 4, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. I have what? 4, 0, negative 4, 0, 4. This is my graph. Okay? Any questions about that graph, that last example that we've done today? Any questions? Okay. Well, this ends another class of 113.